Hello, everyone. Welcome to the Electric Vehicle Infrastructure webinar. We appreciate all of you for joining us today. My name is Vanessa Talania. I'm the new co-coordinator for Silicon Valley Clean Cities. Okay, real quickly, I want to go over the agenda for today. I will begin by covering the Clean Cities program overview. Then we have a lineup of two wonderful speakers to share information on EV basics, fleet analysis, and infrastructure procurement and installation. Then we'll have time for questions and discussion, and then we are done at 11:30 a.m. And I also want to remind everyone some housekeeping rules. Make sure that your computer audio is turned on and use the chat or raised hand feature to participate. And please hold your questions as much as possible in the end. And be flexible and understanding. We're all adapting to these times together. So let's do that. Okay, all right, let's dive in. So who are we? Clean Cities is a government industry partnership in the United States that provides regional coalitions with information and incentives from the United States Department of Energy. Clean Cities was established in response to the Energy Policy Act of 1992. It is community-based and creates partnerships in the public and private sectors. Clean Cities' goals is to reduce petroleum consumption and reduce greenhouse gas emissions. Transportation accounts for more than 70% of US petroleum use. The program has saved more than 8.5 billion gallons of petroleum since 1993. There are about 75 Clean Cities coalitions nationwide, covering about 80% of US residents. On the map, our office is in San Jose, California, just below San Francisco. Each coalition is led by an on-the-ground Clean Cities coordinator like myself, who leads projects and activities unique to their region, educating and helping stakeholders solve problems. Clean Cities uses a three-pronged approach to cut petroleum use by replacing petroleum with alternative and renewable fuels, including biodiesel, electricity, ethanol, hydrogen, natural gas, propane, and other fuels. Also, by reducing petroleum consumption through smarter driving practices and fuel economy improvements. And lastly, eliminate petroleum use through idle reduction and other fuel-saving technologies and practices. Our coalition is Silicon Valley Clean Cities. We were established in 1994. The areas that we cover are Santa Clara, San Mateo, San Benito, Santa Cruz, and Monterey counties. We're hosted by Breed California of the Bay Area for the last decade. Breed California of the Bay Area is a local nonprofit here in San Jose that is over a century-year-old. And as the local clean air and healthy lungs leader, our mission is to fight lung disease in all its forms and works with its communities to promote lung health. Clean Cities focuses on four major activities: local partnerships, information and education, technical and problem-solving assistance, help getting financial assistance. Local partnership convenes key community and business leaders to develop and implement projects, leverage resources, and address local barriers. Information and education has data-driven tools to help consumers save money on fuel costs and help fleets understand their options. And technical and problem-solving assistance, Clean Cities experts help local leaders address permitting and safety issues, technology shortfalls, and other project implementation barriers. And lastly, help getting financial assistance. We inform stakeholders of federal, state, and local grant opportunities, although we don't provide financial assistance. Okay, Silicon Valley Clean Cities Coalition has about 235 stakeholders, about half from private sectors and half from public sectors like cities, counties, and schools. Stakeholders include fleets, product and service providers, environmental and energy agencies, as well as advocacy agencies. Silicon Valley Clean Cities Coalition build relationships and strengthen markets through local partnerships by connecting fleets with fuel providers and industry partners, training and information, technical assistance, identifying funding, providing public recognition, collecting data, and tracking progress. We have two speakers today, Sarah Fischer, who is an electric vehicle specialist at Electrification Coalition. Sarah's work is focused on supporting the Climate Mayor's electric vehicle purchasing collaborative in facilitating fleet electrification across the country. She provides technical assistance to these fleets in the form of fleet analysis, policy development, procurement support, and training workshops. Prior to the Electrification Coalition, she completed an AmeriCorps term serving at the City of Cincinnati's Office of Environment and Sustainability. At OES, she helped implement an energy management system for 400 plus municipal utility accounts and assisted in the creation of an electric vehicle educational program called SVCCC. And our second speaker, Marilyn Luett, Director of Business Development at Black & Veatch. Marilyn leads sales and partnerships in clean tech, distributed infrastructure, and sustainable transportation for the Black & Veatch Transformative Technologies business line. The group has extensive experience in design and engineering, utility and permitting services, procurement, and construction of electric vehicle charging infrastructure, fuel cell vehicle and filling station networks, and behind-the-meter energy storage. Marilyn has over 20 years in clean tech, life sciences, and software industries. Her previous experience includes management positions in the electric vehicle division of Schneider Electric, Akamai Technologies, and TechSoup Global. Marilyn holds a BA in economics and an MBA in sustainability management from the Presidio Graduate School. So Sarah and Marilyn, thank you so much for your support and spending your time with us today. I'm going to pass it over to Sarah to cover EV 101 and fleet analysis.
Thank you so much. I will share my screen. Can you see these slides okay?
Yes.
Yes, it's working.
Perfect. Well, thanks everyone for joining us today. As Vanessa mentioned, my name is Sarah Fischer and I am an electric vehicle specialist at the Electrification Coalition. Today, I'm going to cover some EV basics, reasons to go electric, and really just kind of that intro knowledge so that we're all on the same page in EV terminology. And then I'll also briefly touch on fleet analysis and some tools you can use to get started in that area. I will make sure to save time for questions at the end. So if you have any, please do put them in the chat or write them down, and we'll try to get to as many as we can after both presenters have gone. So let's make sure I can transition here. So just a little background on the Electrification Coalition. We are a nonprofit organization founded about 10 years ago. Technically, we're based out of DC, and we do have an office there, but a good majority of our staff work remotely from different places across the country, even before the pandemic. So I'm currently based in Seattle, originally from Cincinnati, Ohio, if we have any Midwesterners. Midwestern transplants on the call, but we have staff in Columbus, Louisville, Atlanta, Sacramento, Denver, really all over. The mission of the EC is to facilitate the deployment of EVs on a mass scale. So we've been working in this space for quite some time, and we have a number of different approaches to that mission. I work most closely with public fleets that are part of the American Cities Climate Challenge and work with them to promote EV-friendly policies, local adoption, and different things like that. We also have a policy team that works on federal, state, and local level policies. We have served as technical experts on consumer targeted campaigns, including Smart Columbus and Drive Electric Northern Colorado. And we're currently launching our first freight electrification pilot, which is helping a large private fleet roll out heavy duty EVs for freight and goods delivery. So the EC is a little different than some other organizations in this space because we look at EVs primarily as a national security solution above anything else. The EC was established as a sister organization to another nonprofit called SAFE, or Securing America's Future Energy. And the goal is really to reduce our country's dependence on foreign oil. Oil is an extremely volatile commodity, and relying heavily on it puts our economy and our operations at risk. The US is the world's largest consumer of crude oil, using nearly 20% of the daily global oil demand. And 92% of our transportation sector today is dependent on oil-based fuels, which is responsible for 70% of our petroleum consumption. So because oil markets are manipulated by OPEC and other national oil companies, our dependence is an economic and national security risk. As you can see in this graph, most petroleum-based fuels have had a very volatile price over the last 2 decades. And if you look at the light pink bottom line, you can see that electric has historically been less expensive and much more stable. And this graph is presented in gasoline gallons equivalent, so the price per unit of energy is normalized between those different energy units. And then really quick, here is just a more granular view at electric prices. When electric energy prices stay stable like this, consumers and fleets are better able to budget for their operations and are insulated from global price shocks. And because we already have an expansive electric grid, electric vehicles are one of the best scalable alternatives to reduce oil dependence. And they also reduce our carbon emissions, which I will go into a little bit more later in the presentation. So, like I mentioned, we're going to cover some EV basics. Some of you may already be familiar with these terms, but want to make sure everyone is on the same page. So first, we always like to talk about how there are really 3 types of vehicles people generally think of when it comes to EVs. The first is a traditional hybrid vehicle, which we don't actually consider an electric vehicle. A hybrid vehicle has a traditional internal combustion engine, or ICE, as you might hear me refer to it. It also has an electric motor and a battery, but the battery can only be charged through regenerative braking or energy from that gas engine. Regenerative braking is when the vehicle recaptures that kinetic energy of a vehicle slowing down and stores it in the battery. So then that energy can be used to assist the gasoline engine in operating the vehicle. But for all intensive purposes, it's a gasoline car with an efficiency assist. Definitely better than a traditional ICE vehicle, but not considered an EV. So the first actual type of EV is a plug-in hybrid electric vehicle. This vehicle also has an internal combustion engine and a battery, but the battery can be plugged in and charged to power the car completely independently of the gasoline engine. Some PHEVs can travel up to 100 miles on electric alone before needing to switch to the gasoline engine. For many drivers, you can travel mostly on electric for your daily needs and only use the gas engine for longer trips. The second type of EV is the battery electric vehicle or all electric vehicle. This is the type people traditionally think of. So it has only the electric motor and battery. The batteries are charged by plugging the vehicle into a power source. Because there's no internal combustion engine, there are no tailpipe emissions produced. Here are just some quick examples of each type of vehicle to help make the distinction. One of the most famous hybrids in the US is the Toyota Prius, but many other manufacturers make hybrid versions of their traditional gas models. So the Honda Accord and the Hyundai Sonata Hybrid are examples of those. To make things confusing, Toyota does also make a PHEV called the Prius Prime. That Prime can be plugged in, and I believe it gets around 25 miles all electric before it switches to the hybrid gas mode. The Honda Clarity PHEV and the Kia Niro PHEV are also examples of this type of car. In all electric models, some of the most well-known are the Nissan Leaf, the Chevrolet Bolt, and any model of Tesla. The picture on this slide is a Model 3. When we're talking about charging an EV, there are typically 3 levels people refer to: level 1, level 2, and level 3, or DC fast charging. Level 1 charging is the most basic and the slowest method. Most EVs will come with a level 1 cord that can be plugged into a traditional 120 volt home outlet. And this method of charging adds about 5 miles of range per hour. For example, I have a Chevrolet Volt, which is a PHEV. It gets about 53 miles electric. I usually plug it into a level 1 outlet when I get home. And if it was completely empty, it would be fully charged in about 12 hours before I got up the next day. Level 2 chargers use 240 volt outlets. So these are the same type of outlets used by large home appliances like dryers. So you would probably have one in your home for something like that. Level 2 charging adds about 15 to 30 miles per hour. This varies a little bit based on the amperage that the outlet can give and the amperage that the car can take. Traditionally, all electric vehicle owners might upgrade an outlet in their home or their garage or somewhere that they can park their vehicle to charge faster. And this is also what most public charging stations currently are. Level 2 public charging stations are also mainly at places that you may already be at for a significant amount of time. So grocery stores, gyms, things like that, where you might be sitting with your car parked for a significant period of time. DC fast charging is obviously the quickest way to charge, as the name suggests. These public stations are generally at 480 volt circuits and can add 40 miles in 10 minutes. These types of charging stations are really being installed along highway corridors so that EV owners can charge up really quickly on long drives. So the next thing to note is that each charging port is a little different. In the US, there are 4 main port types that you'll see: the J1772, the CHAdeMO, CCS combo, and the Tesla combo. The J1772 is the port that most EV models will have and is used for level 1 and level 2 charging. The CHAdeMO and the CCS combo are used for DC fast charging. More manufacturers are leaning towards that CCS combo as the standard port, but the Nissan Leaf, for example, still has that CHAdeMO port for DC fast charging. Tesla is the exception. They have their own unique port, even for level 1 stations. So only Teslas can use Tesla charging stations and superchargers that you'll see everywhere, although they have said that they're working on opening that up to other non-Tesla models. Non-Tesla DC fast charging stations in the US generally still come equipped with both CCS combo and CHAdeMO ports, but there is discussion around it shifting to just CCS combo for a number of manufacturers. I should also note that most PHEVs don't come equipped with ports for fast charging because their EV ranges are so small. It's generally not something that manufacturers will spend extra time and money on. So with my Chevy Volt, I can only use level 1 and 2 charging. And on long trips, I use the gas backup, but 99% of my driving outside of that is electric. Another concept within charging is networked versus non-networked stations. So networked stations are those that are connected through Wi-Fi to a larger network. Users can start or stop a charge, check the charging status, pay through a mobile app if the charging station requires payment. You can get smaller networked chargers for home use as well if you want to track your energy usage and charging speeds with more detailed data. Non-network charging stations are really just the opposite. They're not connected to a larger network and they can't track data. You really just plug in and unplug, but a lot of consumers and some businesses will go for this kind because they're usually less expensive to install and operate. So these are just some examples of the many charging station vendors in the US. ChargePoint, Blink, Electrify America are pretty big networks that you'll likely see in many cities. And now a lot of people will say that they don't think there are enough charging stations for EV drivers. Something I always like to point out is that most EV drivers do most of their charging at home. Owning an EV is a lot different than owning a gas car in that one aspect. You don't have to go somewhere to refuel. You can plug your car in and let it charge overnight while you're sleeping. So there's no more going out of your way to find a gas station unless you don't have at-home charging. Most Americans really only drive 29 miles per day on average. So most of the PHEVs and all of the BEVs currently on the market have that range. If for some reason you do need to drive farther, or you're going on a long trip, or you don't have that home charging availability, the number of charging stations is growing. This graph is a little outdated, but as of 2018, there were over 60,000 public stations in the US. And that doesn't necessarily include private stations that apartments put in for residents or that businesses install for them employees. So just to give you an idea, this is a map of some of the charging stations in the greater Silicon Valley area. Most EV drivers use an app like this. PlugShare is pretty popular and it helps you find stations around you. It tells you what type of port they have, what level they are, if you have to pay for parking or electricity, if someone's using it, and more. They even have a check-in option so that drivers can leave comments if a station is broken, or if you need to ask someone inside a business for a code or really anything that you might need to know about the station. So really quick, I'm gonna cover some of the big reasons to go electric. I touched a little bit on the national security reasons for switching to electric transportation in the beginning of the meeting. And now we're gonna give a little bit of background on how EVs can save money and reduce emissions. So one of the questions I get a lot is, are EVs really environmentally friendly if the electricity they use comes from a source like coal, for example? And the short answer is yes, they absolutely are, and on average about 50%. The reason is because electric cars use their energy much more efficiently. So in a traditional internal combustion engine, only about 12 to 30% of the energy from the gas that goes in the car is actually used to move it down the road. About 70% of it is lost as heat from combustion. In an electric car, 80 to 90% of the energy from the electric is used to move it down the road, which means the vehicle goes farther per unit of emissions. The graph, this graphic is based on the average electricity makeup of the US. So on average, the US doesn't have a ton of renewable energy yet, and the BEV still has about 30% of the emissions as the full internal combustion engine vehicle. As the grid gets cleaner, so will EVs, and that's really the only vehicle on the market today that you can say that about. BEVs can also cost about 50% less than an average brand new gasoline vehicle to fuel. And PHEVs are also significantly lower, although with a PHEV, it really depends on how much you use gas and how much you use electric. This is just another comparison. In addition to being much cheaper to fuel, EVs also require a lot less maintenance because they don't have as many moving parts. They don't require things like oil changes, and regenerative braking has been shown to reduce wear and tear on brakes, for example. So now that we've gone through some EV basics, I want to quickly touch on the market as it stands today. So I apologize, I forgot to change the title of this slide. We're obviously now in 2022, but these are models that originally came out in 2021. So 2021 was actually a pretty big year for EV model releases. A big trend that we're seeing in the new models coming out is larger sedans, crossovers, and SUVs. Market research has shown that Americans really like bigger cars, so bigger models are coming out right now. And you can see many of these are about 40,000 or less. Out of these four, all of them are also eligible for the federal EV tax credit. And another thing to note is that all of these have over 200 miles of range, which is more than enough for most of the daily driving needs of the average American. Another exciting thing that we're starting to see is electric pickup trucks. They're finally rolling off production lines this year and next year. The Lordstown Endurance, the Ford F-150 electric, the Rivian R1T, the Tesla Cybertruck, and a few more are on the way. And we actually already have a significant amount of medium and heavy duty equipment available, including garbage trucks, street sweepers, box trucks, school buses, and transit buses. There is also still funding assistance for EVs as the market transitions. So currently there's a federal tax credit for up to $7,500 per new vehicle purchased. This amount varies by battery size. So PHEVs are sometimes eligible for less than that amount. It is capped at 200,000 vehicles per manufacturer. So as of right now, Chevrolet and Tesla are no longer eligible. There has been talk of legislation to extend those manufacturer caps. So we'll see if they are eligible again in the near future. There is also a federal tax credit for EV charging equipment. So up to $1,000 for consumers and up to $30,000 or 30% of the project cost for businesses. I should note that right now, these are just tax credits. So in order to achieve them, you do have to have a tax liability of that amount or higher. There is some discussion in the new administration as well about changing those so that people could apply the tax liability over multiple years, or potentially making them a point of sale rebate instead. So we'll see if that happens and how that would change. In terms of grants, one of the most well-known are the Volkswagen settlement grants, which are a result of the Volkswagen Dieselgate scandal that happened in 2015, 2016. $3 billion was distributed to states based on the number of vehicles in their states that were affected. And it's up to each state authority managing the money on how they're awarding it. So on rebates and grants, really, some states and localities and utilities will also offer additional funds for purchasing EVs or charging equipment. There are also manufacturers that will offer some incentives. So I'll have to check and make sure Chevy is still doing it. But when they first announced the 2022 Bolt, they would cover the cost of a charging station installation with the purchase of your 2022 Bolt. And I believe the Volkswagen ID4 is coming with a 3-year Electrify America unlimited charging pass. So as I noted a couple of times, the market is certainly changing a bit now that we have a new administration. The Biden administration has really signaled support for EVs in many ways, and we're already seeing the industry respond. So not too long ago, GM committed to 100% electric models by 2035, and there are more announcements from companies like that every day. Finally, I'm going to briefly cover some basics around fleet analysis. So first, I want to really quickly talk about fleet right sizing. And this is a technique used to ensure proper planning, spending, and utilization of vehicles by a fleet. It's really common among public sector and private sector organizations. And the point of it is to make sure that you're not purchasing too many vehicles based on what your fleet actually needs. So you can see in this little graphic example, there are two vehicles that only drive 2,000 and 1,000 miles a year. And fleet right sizing would say that you could combine the usage routes of those vehicles and have one vehicle that travels 3,000 miles a year, which from budget standards is just more efficient and helps save the fleet money. Also can help reduce unnecessary purchasing of new vehicles and can help the organizations move to alternative fuels by shifting more miles onto a specific vehicle. Because as we saw in the cost comparisons, EVs are really money savers by how much they're being fueled. So the more you can use a vehicle, the more cost savings you'll see. Some potential barriers to fleet right sizing that we have seen, just to be aware of, there can be some employee pushback on sharing vehicles. If employees or work schedules change frequently, it might be a little bit difficult to schedule combined use of vehicles, and maintenance might take a little bit more coordination because you have fewer vehicles to deploy while other vehicles are down for maintenance. The biggest one is really just a lack of top-down support or lack of desire for this, but happy to talk through different strategies on how fleets might look into right sizing or get started with that process. These are just good questions to ask when you're starting the process. So how important is each vehicle to the fleet? What tasks are accomplished by each vehicle? Are there any really old vehicles that are no longer cost effective to operate? If they are really old and it's costing a lot to spend on maintenance, that's usually a good candidate for elimination or at least replacement when we talk about fleet analysis. Then you also want to ask, what is the daily, weekly, and monthly mileage of each vehicle, and what are the age of the vehicles? So fleet analysis, moving into this a little bit deeper, is the process of generating the best recommendations of vehicles, possible charging locations, and number of vehicles needed for a given fleet when we're talking about electrification. The process, it really takes into account determining the goals of the organization and what the fleet needs all of the vehicles for. You start out by gathering data on the fleet. So this could be vehicle miles traveled, fuel type, traditional replacement timeline for vehicles. So whether they're in the fleet for 5 or 10 years, and any really important usage characteristics. So does the fleet vehicle need to hold 6 passengers, or is it really only for a single driver? And then it'll help us identify those specific opportunities for deployment and use of EVs. I'm going to skip ahead really quick because I know I'm running short on time. So finally, I wanted to talk about the dashboard for rapid vehicle electrification, or DRIVE for short. This is a tool that the EC developed in coordination with Atlas Public Policy. It's a free Excel-based tool that anyone can download, and I can share the link in the chat after this. But really, it helps identify near-term procurement opportunities. So those vehicles that would be the best candidates for electrification right now. It'll help you compare the lifetime and per mile cost averages of a gasoline vehicle compared to an electric vehicle. So you can see how much money you would save over the lifetime by transitioning to electric. And you can work in a number of different settings like fuel costs, different incentives that you want to add in, different things like that. And really the only inputs that you need to use the drive tool are the VIN and then vehicle miles traveled annually and use replacement cycle. Other costs that you can put in but are rough estimates are okay are gasoline and diesel prices, electricity prices, value of a local incentive rebate, or really anything else that the city or fleet is interested in seeing in the analysis. And I will, I'll share this slide deck afterwards, but if you have any questions, you are more than welcome to reach out to me. Happy to talk more about the drive tool or other projects that the EC has to help support public fleets and fleets interested in going electric. So I'm going to stop sharing my screen now and I will pass it off to Marilyn.
Yeah, thank you, Sarah. Hello, everyone. So my name is Maryline Daviaud Lewett, and I'm going to share my screen too. So bear with me for a second. Probably not this one, but this one. All right. So thank you again for organizing this webinar. Breathe California is a wonderful organization, and Vanessa who just joined, and thanks, Sarah, for giving this great overview of the EV market. I do want to mention that in the Bay Area of California, we are the #1 market in terms of adoption of EVs. And we are at above 10%, which is by far the largest penetration of EVs at all combined, cars, buses, trucks on the market. And California, the state, is also by far the #1 for the adoption. It has a lot to do with the early adoption interest that the market has in general with technology, of course, sustainability-minded person, gas emission issues we have in California, and also the support from the state and the different organizations we have, public organizations, especially where we have strong incentives. So Sarah talked about some of those, and they've been really, I would say, successful on the market and much more advanced than what you see in some other states. So hopefully, everybody will catch up over time. So I'll be talking briefly about Black & Veatch, a company I represent, and I'll focus more on the infrastructure, which is one of the big challenges in our industry in terms of investing upfront for the charging infrastructure. How can it be set up? And there's a lot of planning around it. So we'll try to give some good insight and lesson learned that we share also a lot with the company. So quickly about Black & Veatch. So we're a very old company. We're over 100 years old, and it's a company based in Kansas City. We are a privately owned, employee-owned company, and we have about over 8,000 professionals across the world, but I would say a good 70% is in North America. And in the Bay Area, our main office now is in Walnut Creek. We used to have an office in San Francisco that we closed just before COVID. And but we have quite a large number of professionals in the Bay Area. Same thing with Los Angeles, San Diego, since there is plenty of work to do here. So we focus all on the services for the construction. So from engineering all the way to construction. And with a really strong focus on safety. So, we're actually in the US, the #1 company in terms of safety record in our industry. So our company works on all type of infrastructure. I hope these pictures here are not in the way of the screen. Let me know if there's if something is in the way. But so company works in power, works in water and wastewater plant, also in telecommunication, but all based on infrastructure. And all this expertise, I would say, got to be applied for the transportation sector. So about 30, I'm going to say 30 years ago, a company made a strategic move, first of all, to focus more and more on renewable. We do come from the standard oil and gas industry. There's plenty of non-clean plants that were built 50 years, 60 years ago. And about 30 years ago, we moved our focus into solar, wind turbine farms, or fuel cells technology, anything you can think of that brings green energy into the market. And from that experience, when the transportation started to look at clean energy for transportation, it was a very smooth transition, I would say. So our company focuses now a lot, especially in the group I represent, on the EV charging infrastructure. We also work on the hydrogen refueling infrastructure. This is not the topic of the webinar, but maybe if the Clean Coalition of Silicon Valley is interested, we could do another webinar on hydrogen because it applies quite a bit to the medium to heavy duty vehicles. So, but back on EV, we have plenty of experience in that field, and I will present to you what is the process to build this infrastructure. First of all, the planning, like Sarah mentioned, is quite important to really have a good understanding of what you're looking for. We're going to talk mostly about the fleet market for this webinar. Our company is now working on residential, and residential, as you know, it's much more simple. You can work with a local electrician who can manage your EV chargers at home without an issue. But for other people who do not have a home, who live in multi-unit dwellings, apartment, and need to charge in other environment, then you either need public charging or you need a workplace charging. And the workplace charging, since many of the cars, at least before COVID, were sitting in parking lot, it seemed very logical to push on the workplace charging. So state of California has done lots of effort in that impact of the market, because also we overproduce solar. Probably most of you know California has a surplus of solar energy. So since we don't have enough energy storage to keep it, it needs to be used every day. So if we can charge during the day, it makes a lot of sense. And then for back at home, at night, of course, charging has a very low cost, so it's good. Also the fleet, school buses, buses who do not run at night, some of the trucks, delivery companies who don't run at night neither, can charge at night. And there's also a good system in place now with the utilities. So all this planning needs to be done and well prepared ahead of time before taking decision, like Sarah said, on the type of vehicles, what are the needs, not oversizing, what you need, and to keep it cost efficient. And then from there, you go into the site acquisition. Most of the fleets do have land that they lease or they own that can be used. But then there is some criteria around the power availability, which I'll talk about it a little bit later. And then we go into engineering. We do engineering design, permitting, utility coordination. All this is done at the same time before we design the final drawing. It's called CD 100, so 100%. Those are sealed and signed by engineers who have the license in California. And then it goes into construction. And our company does construction management and safety management. And then we work with local contractors to do the actual job of installing the equipment. So that's kind of the process that we'll go through in a little bit more detail. But as you know, a lot of the conversions of the technology and clean technology has allowed the market to look into clean transportation. And very pleased to see, you know, more and more OEMs coming into the market for the cars like Sarah presented, but also of course the trucks and the buses, school buses. We have two companies in the Bay Area for the buses. Proterra is one that many of the transit agencies know now, and also Gillig. Gillig is also in the East Bay, so locally owned, manufacturing buses locally, and they do school buses and smaller size buses. And I think those companies are also looking for the trucks market. So not only we have access to, of course, the national market, international market for vehicles, but also at the local level, there's been some very good focus on this market. And of course, you can't forget Tesla that started all this. So has been very good. And then also, like Sarah mentioned, what's really important is to look at the overall cost of ownership. So it's not just about leasing or buying the vehicles, but it's also looking at the maintenance. And usually the maintenance over time is much, much lower than a diesel truck or a diesel bus. In addition of course, providing zero emission vehicles. So fleet managers and operators are very familiar with that term of TCO, but when you compare, you know, traditional fueling versus new technology, you need to look at over a period of 5 years, 10 years, depending of what the fleet profile is. And then another important factor to look at is how long it takes to get the infrastructure built. Typically, let's say that you order, you know, either a fleet of cars, which might come within 6 months, or buses or trucks, which might come in 12 months or 18 months. You pretty much need to start to plan for the infrastructure at the same time as you're planning for choosing the type of OEM equipment you're going to need for the vehicles, because it does really take from 6 months to 24 months to actually build infrastructure, depending on the size of the fleet. And one more element that Sarah also touched upon is there's a lot of incentives in California to benefit from. And beside for the fleet specifically, you have two organizations to really look at. Is the CARB, so California Air Resource Board, has tons of information on the zero emission vehicles and access to grants or subsidies, and also what we call the California HVIP, and they have incentive for clean trucks and buses. And if you go on their website, it's called the ZEV program, zero emission vehicles. So we have, you know, incentives at the state level, regional level, public agencies, and also for residential, like Sarah mentioned, for federal tax credit and the California tax credit. So that has been part of the success of the adoption of EVs in California, and it's good to continue, you know, to use those resources. But that also takes a lot of planning, because you may apply for a grant that you're going to get, you know, 6 months later. So the timing is quite important. This is just an example of what it takes to charge a truck versus, and that's very generic, but a truck versus, you know, how many homes you would heat and, you know, where you use energy for. So the scale is quite different, which brings lots of preparation and some pressure for the utilities to be prepared and be ready. And in addition, like we mentioned earlier, there's all type of fleet, and they all need to be customized and plan with the infrastructure depending of the profile of those fleets. You know, how much autonomy you need, of how many miles are driven per day. There's some idle time, of course, with the school buses and the refuse fleet. So the demand is very different than when you run a transit agency bus program. as an example. So now in terms of site planning, when you need just a few chargers, and again that's done during the planning and working with the OEM. If you work with level 2 charging that Sarah presented, it's quite different than working with DC charging. And this picture here represents a site from Electrify America. They typically deploy 6 to 8 DC chargers, and we're talking of 150 kilowatt to 350 kilowatt. So this type of chargers for the public charging sector is already a pretty high level of power needs. So we usually need to bring additional electrical power, even if you have just a few DC chargers. So you can imagine that for a fleet of, let's say, 50 buses, that scale increased greatly. And that's why the site that's chosen needs to be closely considered in view of the availability of the power. If you're close to a substation, you're going to have a better chance to get quicker power for additional power. If you're far away, the utility might need to do some planning and construction around adding power. That takes also any time between 6 months and up to 24 months for very large hub for a fleet. So lots of planning around this. So we have also, indoors parking lot, outdoors parking lot. The indoors parking lot infrastructure is much more expensive to build than when you're outdoors. So something to think about. That's why you often see a charging site with a solar canopy, for example, and instead of being the chargers to be put in a garage, because solar canopy can protect from the element, it protects the charging station, but also it's actually quite cheaper than to go in an indoors facility. And in addition, of course, solar canopy help produce some local energy, green energy. It's not enough to charge a fleet, but it's a good complement to have. So there's a lot of detail here in the next 2 slides of what to consider, the grading on the parking lot. There's ADA requirements that are different from at the state level, but also at city level. And we have to pay really close attention to what those requirements are, especially for public charging, but also for private charging, even for behind the fence. The right of way, there's just multiple elements to take into account. I will share that deck too, so you will have this type of information available if you're interested. Regarding the design and utility coordination, so same thing, all this is done ideally at least 6 months ahead of when you're going to acquire or receive your EVs. Of course, if it's a small fleet, it's going to take much less time than a large fleet. But we go from we do a site work first, our team, but any contractor will do that. Any vendors and EPC firm will do it. We usually go on a site work to do an evaluation that what's there and the power available on the site, but also, what is the best configuration? Where do you put the charging station? What makes sense, especially with medium to heavy duty vehicles? They need to have enough of a traffic flow to system to be able to not back up into a chargers, to have a smooth way of traffic circulation and flow. So all this is planned ahead of time, and that's how we go to those CD30. It means 30%, 50%, 90%, and finally they are signed and sealed by an engineer, PE. And same thing, all the utility coordination is done at the same time. So it's very important to engage your local utility at the same time. So we're doing all this work. Then comes the permitting. Permitting can only be done once you have those CD 100 sealed and signed. And sometime at CD 90, we can have discussion with the local jurisdictions. They are the one who give the permits. And there are specificities per town, city, jurisdictions. So That's why work is really highly customized, and more we know about the local, jurisdictions and what their preference are, less time we spend on the preparation of the design, and we're more cost efficient that way. But this permitting process also can take from anywhere between 3 months to 6 months, sometimes longer. So it's, also if it's public charging, it's a little bit different than private charging. And finally, we talk about the utilities, but there are, of course, some big challenge coming. There hasn't been so far too much, because the utilities in general in California had capacity to expand this infrastructure to provide power for the EV chargers. But as we move forward, as you know, in 2030, 50% of the market needs to reduce the diesel fleets by 50%. And by 2040, it was supposed to be completely diesel free in California. So there's lots of work to do, but this need for power, and ideally, of course, green power, renewable power, is gonna accelerate the exponential level. So tons of preparation needs to be done, and that's why the utilities do like to be engaged, I'm going to say, early on in the process, to make sure we're doing some good planning with them. And finally, the construction process, pretty classic, just like any building you would build. Infrastructure is fairly similar. It doesn't require as much equipment. Of course, it's a lot about building conduits and running cables for the power, for communication, usually too. We don't always have the level of signal, the Wi-Fi signal that you need for the charging station. So sometimes we need to run fiber for communication. As Sarah mentioned, all those charging stations are monitored. The data is monitored. We use RFID cards. If you're an EV driver owner, you might have 2 or 3 different cards from ChargePoint, from EVgo, and other cards in order to unlock the charger, and then it's connected directly to your card. And there are other systems, but they all need communication. And of course, the company that provides charging station do collect the information on the profile of the users and how often their charging session are used. So communication is important. So I just wanted to, visual persons, I just wanted to give you some example of what it looks like. I'm sure you're very familiar with those charging stations because you see them in the Bay Area everywhere. So we're lucky because charging infrastructure have been built over the years at a very rapid pace. So our company has worked with Tesla. We've built about 400 sites nationwide with them. We started about 6-7 years ago. Tesla works with other vendors as well, of course, but we do a good chunk of it. Same thing with Electrify America. We talk about the Volkswagen funding. So when there was a Dieselgate software, fraud that took place, the EPA settlement ended up being for the Volkswagen Group of spending $2 billion in 10 years across the US in a period of their full cycle. We're just entering cycle 3. And out of those $2 billion, $800 million were assigned to California because this is where Volkswagen was selling the most diesel cars. And so there was a direct correlation between the sale of the diesel vehicles and the impact, of course, on the air and the gas emission in the different states. So it just happened that California is the #1 car market and trucks market. So Volkswagen had to spend a good chunk of that $2 billion in California. So we all benefit from it. You see the program, the Electrify America program. If you go on their website, you see where the chargers are, and those are all high power chargers. There's no AC charging, so DC charging. and they're doing a good job, I think, about putting those charges in the right location. So those funds can only go for the public charging. And then Sarah mentioned of the other funds from the Volkswagen do need to provide at the state level, and that can apply to the fleet market or for also what they call a green city. There's a green city program. Another thing I wanted to mention that we're involved in, so PG&E or some other Bay Area utilities are launching such a program. It's called Make Ready program. The Southern California Edison one is called Charge Ready, but PG&E has the Make Ready program, and some other smaller utilities do have those too, where you can benefit from the utilities to invest in the infrastructure themselves. So some of the utilities have been deregulated, first in California, now it's happening in some other states. And they're allowed by the PUC to allocate part of their budget into the infrastructure. So it's called Make Ready program. But depending on the utility of your territory where you operate, you check with your local utility which type of program they have. You can send an application if you're planning to build infrastructure for your cars or trucks or buses, and they have program for the fleet as well as for workplace charging, multi-unit dwelling charging, etc., etc. So a really, really good system. And again, California was the first one to provide those. Those are just example of, the bus market. Now we're building those pantograph system that are quite cool. Instead of charging station, it's charged from the top. So it avoids all those cable that we have everywhere, which are a safety issue, depending of where they were. So this system is pretty good and safe. And this is applied only for the bus market for now, but we think that the truck market will benefit from those systems. This is another example, just a great picture of a local company. So those buses are from the company Gillig I was mentioning to you about. They're from Livermore, and they've done a great transition into electrification of the buses that they manufacture. And this is in Vail, Colorado, but so I think also the wrapping of the bus is quite nice, and they've done a good job when you go in the mountains to see electric buses instead of diesel buses, of course. One more thing that's just starting to come on the market is for the truck fleets is also not only there will be a private hub behind the fence, of course, for the fleet, but there's more and more companies are considering building a shared charging station for the trucks market. So all those corridors that we need to cover, from California to Oregon, Washington, D.C., all the way to Canada, we can envision that there will be high power charging station available to the fleet market that would be open to multiple fleets. So it would not be one fleet per infrastructure hub, if you will. And that's all about these ideas about sharing the cost and maximizing also the infrastructure, since it's quite expensive. So this one is based in Portland, Oregon. That's it. So this is just the step that we just talked about how to prepare. Do you need to do some planning when you're looking into acquiring or leasing an EV fleet or even a few cars? All the way from the profile of the fleet, what you really need, sizing, the right power, sizing, the numbers of chargers you need. You don't always need to have DC charging. If you can charge at night and it can be slow charging, there's huge cost saving right there. So sometimes it's a combination of level 2 and DC chargers that needs to take place. And then you go from this planning all the way to engineering that we review, the permitting. Our company, but many other companies do that at the local level, regional level, and national level. And then the lesson learned is really about starting early that process. As I mentioned, it takes 6 months to 24 months, depending on the size of the infrastructure, to be actually developed and built. And the other thing that we're seeing right now is the electrical equipment has more and more delays. All the companies like Siemens, GE, Schneider Electric, and all ABB, all these companies that provide switchgear and electrical panel board, having, of course, more and more demand on their equipment, and the delays are increasing, especially since COVID for the supply chain issues that everybody is familiar with. So that's why you even need more planning around what you're going to need and when. And that's it. And this is just example of a documentation that are targeting the fleet market that we provide on our website. If you have interest to dive in much more, of course, than what I presented, you have access to those. They are free, available to anybody. And with that, thank you very much. I'll bringing it back to Vanessa. Vanessa, you're...
All right. Okay. Thank you, Marilyn and Sarah, for that informative presentation. Now we're going to open it up for questions and discussion. So you can use the raise hand feature or tap it in the Q&A box. Okay.
Yeah, I can. Well, really quick, I'll touch on two questions that I answered earlier in the chat. The battery recycling question is something that we get asked about a lot, and the short answer is yes. There is no one-stop solution for battery recycling right now, but there are just massive amounts of research going on in this field, and a number of the OEMs that actually produce the batteries are working on processes for bringing them back and recycling them at the end of the life cycle. So off the top of my head, I know Nissan, Volkswagen, and Renault are working on that. And I think it's kind of one of those things that since the technology is so new, not everything has been 100% decided, but we've had gas cars for so long, it's kind of hard to compare gas vehicles to electric vehicles in that process. It took a while for us to get a solid recycling process down for the lead acid batteries that are in most traditional gas vehicles that are on the market today. But there's definitely opportunity in that area, and there's some really great research and some amazing studies. If any of you are interested, happy to share the links on that. And then the registration fee and gas tax issue is something we also get asked about a lot. I recently moved to Washington State from Ohio, both of which have regressive EV fees. So I've looked into it a lot, and most of the states that are kind of concerned about EVs not paying into the gas tax have instituted these registration fees that really just aren't fair, in the sense that they're a flat fee on electric vehicle owners that doesn't consider how much they actually use the roadway infrastructure. So you as an EV owner that drives 30 miles a year could be paying more in that infrastructure support tax than a heavy diesel truck that drives 5 times as much as you. So there's a really good article or an analysis by Consumer Reports that kind of looks into each state that has those registration fees and whether they're fair or not, which I'm happy to drop the link in the chat too. Outside of that, I mentioned in the chat that Washington State is looking at implementing a pilot program that actually tracks how much vehicles drive per mile based on their odometer readings per year, which could be expanded across the board for both EV and gas vehicles. And that would look a little bit more at how much you're actually using the infrastructure that you're paying for, rather than charging you based on gas or the fact that you own an electric vehicle. So hopefully we'll get to see more about that if that passes in Washington State this year.
Thank you, Sarah. Also, someone asked, are the 2 presentations going to be available? The answer is yes. We will make the recording of this webinar also available. And you can check that out on our Breed California website. This question is for Marilyn. So do you provide additional services like fleet management and maintenance after installation?
Yeah, good question. So most of the time, the operation maintenance is provided by the OEM of the company you'll be working with. So Proterra would do their own, Gillig's going to do their own. And for the charging station, same thing. ChargePoint, EVgo all have structures for the fleet management services with software platform, but also the maintenance of the charging station. We typically don't. Once we've done the installation, we are responsible for the electrical equipment and to make sure that it's working and it's providing the right amount of power. But yeah, O&M is usually done by the manufacturers themselves.
Okay, thank you. And how would one accommodate for future expansion for charging infrastructure if there was already one in place?
Or for expansion.
Mhm.
Yeah, it's all managed depending on what the needs are, of course. So usually you need to ask an engineering company to go on site to really do a site work to evaluate what's on the site and what is needed for expansion. So it has a lot to do with the profile of the fleet and let's say you have 5 buses and you want 10. Okay, and it was not planned ahead of time, so you kind of need to redo the work that was done originally. Not so much to dig in the conduit and all that, but it's more about the evaluation of what the power and what's available. And what happened is as the fleet grows or more power is required, sometimes the utilities are offering different systems, and if it's important for you to have green energy and to charge at night, that means that you might need to have an energy storage system locally in place on the site in order to capture the solar energy from the daytime production and then being able to charge at night. We call that off-grid. Really, it's an off-grid system to be able to charge at night. But the planning is similar. We just try to not reopen the conduit and find a system to expand from there. That's why early on in the planning, if you have expansion 5 years to 10 years from the initial installation, when we know that, we can also prepare the conduits to have the size required for future expansion. And then usually you do need to change a transformer, you need to change a switchgear, et cetera, et cetera.
Okay, thank you. This next question, it's open for the both of you. So what are some zoning and development code requirements, and what challenges might we expect or have you encountered in the past?
I'm just going to say that it varies. There's not one standard for the zone and the code. And of course, we follow the NEC code. All the equipment have to be UL approved. We don't install anything that's not UL approved. And most of the other companies would do the same. But after that, all the specificity per site, per location depends on your local jurisdiction as well as the utilities. Sometimes the utilities have some requirement also for the infrastructure that are specific. Sarah, you might have.
Yeah, I'll echo what Marilyn said. I just did a number of interviews with cities asking them about barriers like this. And I would say most of the cities didn't run into zoning issues or barriers. There were a handful of cities that said just locally they happened to have bureaucratic hurdles about the number of different permits they needed for they needed separate permits for electrical conduit installation and a separate permit for running new service to a specific site. So it is really local. One city, they wanted to really make sure that their charging infrastructure was ADA compliant, not necessarily an ADA marked space, but they wanted to make sure it had all of the exact characteristics of an ADA space so that it was accessible by everyone. And they said that process and trying to make sure that they had all of the right curb cuts and the correct incline percentages and everything like that took a little bit longer, but that was a consideration that we hadn't heard of a lot of installations taking into account.
Okay, thank you. And then lastly, we have, let me see here, where did it go? Whether it's for financing, sourcing vehicles, or driving uptake in the community, how can public-private partnerships help local governments meet their EV goals?
Yeah,
Yeah.
yeah, no, go ahead. Go ahead, Sarah.
I think there have been a number of different examples of really good public-private partnerships, especially in the charging infrastructure space. We've seen a lot of growth in the space that public fleets and public landowners leasing out their space or offering up their space to private charging station companies. And then the private charging company will pay for the installation and operation of a station just with the permission of the public entity to use that land. So there are examples there. There are also some really unique examples and pilots coming out around equitable EV car sharing that are collaborations between public, private companies, nonprofits, affordable housing communities, things like that. And I think there's just a lot of really good work going on in that space, specifically when it comes to equitable deployment. Utilities, I will also say, are a really, really good example of public-private partnerships in some cities. Orlando Utility Commission, Georgia Power, and I'm blanking on the name of the Austin utility, but I think those are all some really good examples of where utilities have really helped provide funding and expertise for public fleets and city departments that are looking to expand EV adoption in their communities.
And to add to that point, that when we talked earlier about the Make Ready program, those are the ones that are designed to really help private sector, public sector to have the right funding to build infrastructure. So the utilities have been really good about that, and it's expanding now. The utilities you mentioned definitely work on it. You have Excel Energy, Duke Energy also working on it. But I have to say, I've worked in California for over 15 years, 20 years now, and the PUC deregulated our utilities early on, so there's a lot of learning from what has been done in California on this market, and the utilities are really good about sharing their learning from those Make Ready programs. So actually, you have a lot of information on their website. And then maybe we can touch upon talking about public and private. There are companies right now, more like energy type of companies, who are offering charging as a service, energy as a service. So instead of the fleet to take on the build of the infrastructure themselves and figure out where is my power coming from. I would like green power, but I'm not going to build a solar farm, on my land. I don't have the space, etc. And also it's a different job, right? The fleet operators don't necessarily have all the expertise that's needed to find the perfect technology that's going to work for them and the infrastructure. So now you have companies that are providing this type of service as a third-party service. This way you're going to pay per kilowatt hour, for example, or kilowatt, and then they're going to take care of all the infrastructure for you. And some of those companies are working in collaboration with the OEM that you're going to choose. If it's Daimler or Volvo, or we talked about Proterra locally or Gillig, they all have partnership with energy company that can provide this type of service. And then us, we come after. We're not really in touch directly with a fleet operator because we are just like a subcontractor, if you will, from those energy companies. And this way you deal with only one entity, which is I think a pretty good system. Even company like ChargePoint, which is, as you know, in Campbell in California, the same thing. They actually offer charging as a service now. They have a full platform. They just don't sell the charging station and their software system. They do offer turnkey solutions. So this is coming on the market, nicely as the market is evolving. And also being able to have access to we talk about the renewable energy. Sometimes some utilities, local utilities, just don't have enough access to the green energy. So they need to find what's called PPA contract with the larger energy company to provide green energy. I live personally in Marin County. MCE was created in Marin County as a program to have access to green energy that PG&E could not provide, for example, where I live. So even if you don't have your own solar panel on your roof, then you do have access to solar or wind turbine farm energy. So all this is available now on the market.
Okay, thank you. Okay, so one more question. This is more of a residential question. How do I determine if I have enough power for my charging station?
I'm just going to say it's unlimited. I've been driving EV cars for 10 years. So I first had a Nissan Leaf, and then there was 120 miles range, really small. But now I have the Chevy Bolt. I have 230 miles range, which I'm really happy about. The power at home is unlimited. As long as you're connected to the grid of the local utility, you're never going to run out of power. The only time things happen is that if there's a power outage, of course. So let's say during the fires we have in California, you have power outages, then you can have a challenge with charging. So you might have to charging in a public charger. That's when you need the public chargers. And then you have solution now to also bring power. We talk about energy storage. You can have a home energy storage system. Tesla does one, but there are some other ones coming on the market that are great and gives you autonomy for 2 to 3 days, for example. So, and Sarah, yeah, I'm sure you have much more to talk about with that.
Yeah, I just to clarify with the question, you always have level 1 outlets that you can charge your vehicle on. If you're looking at installing a level 2 charger at home, that would be something where you would really just need to have an electrician come in and double check that you have the correct circuits so that you're not going to overload, a circuit that also has a dryer or something like that on it, or to run the conduit to your garage so that you can charge in that location. It's the same thing that I always tell cities. We can help identify good locations, but in any case, you're going to want to make sure you have an electrician come and actually look at the service to make sure you won't overload it.
Okay, all right. Thank you, Sarah and Marilyn. Okay, so that looks like that is all the questions that we have for today. So I just want to say thank you.
There was another question from Kyle in the chat.
Was there? Okay.
Yeah, which I'm happy to touch on. I know we're kind of running low on time. So Kyle, I can also drop my email in the chat and you can feel free to email me. But touching on the first question about the California wanting to phase out gasoline powered cars by 2035, that's cars sold. So it's not saying that by 2035, if you have a gas car, you're not allowed to drive it anymore. It's just all new cars sold by 2035 need to be electric. And there are exceptions to that rule for, vehicles that aren't technically available yet. Assuming that they are available, then ideally manufacturers would only be able to sell those EVs in that location. In the power, where's power coming from to charge so many vehicles at night? At night is actually the best time to charge vehicles still. Most utilities will actually offer off-peak discounts for charging vehicles at night because industry and business and other things like that aren't using power. In terms of, I'm assuming you're saying no solar or wind assistance. I mean, there absolutely will be energy still supplied by renewable power plants at night, maybe not solar, but there is wind available, there is hydropower available. We're not there yet to transitioning the entire grid to renewables. Hopefully we will be someday. When that does happen, there is also a lot of research and products coming out, as Marilyn mentioned, with battery storage. So there are whole homes that are run off grid of battery storage now, and they're looking at creating more microgrids in that sense that will have that kind of backup battery power storage. But for now, charging at night is actually a very good idea. So definitely happy to share more information about those off-peak rates and where you can look for those kind of discounts and utility programs surrounding that.
Okay, thank you for covering those questions, Sarah. I completely overlooked that one. Okay, so again, thank you so much for your support. It looks like that concludes our webinar for today, and you will hear from me to have the recording and the presentation slides available. So thank you, everyone.
Thank you very much too. And you'll have a contact information also if you can take some questions offline over email. No problem.
Thank you.
Bye-bye.
Thank you. Bye-bye.